Hello, my good friends. Another little bit of interesting unknown things today. What is the Schumann resonance and why is it important for your mental health? And I think it's important for your mental health because our brain waves run on this resonance. Now, what is the Schumann resonance? We're going to be talking about it in a minute, but let's talk about the health effects of it first of all. Mother Earth's natural heartbeat is 7.83 hertz, a very, very long wavelength. It is literally 25,000 miles long, which is the circumference of the Earth. And that's why these waves bounce all around the Earth inside of an envelope, which isolates them from and allows these transmissions of frequencies around the Earth, and to send out global transmission, satellite transmissions, all that kind of stuff. They bounce them off the ionosphere. Now, so what do they have to do with our health? Well, a 7.83 figure is also an alpha theta brainwave frequency in the human brain. And what does it do in the human brain? Relaxes you. It puts you in a dreamy state, a sleepy state. I think it might be the REM area or whatever it is, but it's where you are relaxed and feel comfortable. People don't feel that anymore. Nobody feels that. I don't feel it. I don't know how you feel. It is no surprise that the people nowadays, especially in the bigger cities, unbalanced, irritated, reactive, angry, disease, all kind of problems going on. And this is, we're more than just a bunch of water and chemicals in a bag. There's a lot going on here, and there's frequencies, and frequencies are everything, and there's only certain ones, and they have to be resonant. If they are not resonant, they fall apart. And if they fall apart, there is chaos. And where there is chaos, there is turmoil. And the Earth is in turmoil right now. We have gone away from our resonance frequency. And I believe it's because we're crashing into some ether in space that is denser or some problem that's going with it. And it's crushing our atmosphere, as I have explained in many videos. I'm probably going to do it in this one, I don't know. But it is something I think even maybe the Mayans and all the old cultures knew. They followed the heavens very, very, very carefully. And if you look at the cycles, there's 11-year solar cycle, there's all kinds of cycles. They knew about this. We maybe say that, well, when we get to 2019, boy, you guys are in trouble. Let's go to the inside of the Earth. I don't know what they did, but all of a sudden they're gone, and now here we are in a situation where I think we got a situation that we should really be looking. I mean, I don't know what we could do about it, but it could be that it could be just something we're just missing, and there might be something we can do about it. But it's not going to be done about it anything because nobody's cares about it, to be perfectly honest with you. So let's see what resonance frequency is all about. All right, my friends, this is serious. I know I'm going to start laughing because it's almost like a zombie apocalypse. I'm telling you, because these people are turning crazy. People are turning insane. There's a woman on the news the other night in a supermarket calling 911, screaming, absolutely insane. And people are killing people and doing all the worst possible things. I never saw anything like this. And even the Earth itself is in turmoil. All you got to do is look around the floods and the this and the that. I mean, maybe it's just all natural, but maybe not. And why wouldn't it be natural? Well, there's a thing called a Schumann resonance frequencies. And we say, well, what is that? We say there's a number of different frequencies in the Schumann resonance. And a frequency is the distance of a wavelength, which is nothing more than a measure of electric current, really. Now, why is the frequency changing and why is the electric current increasing? Well, it's because we are plowing through ether, which is negative particles in the atmosphere. This I am certain of. Our magnetosphere, way on the outside of our envelope that touches space, is 56,000 degrees because it is scrubbing through the ether in space. We're only 75 degrees at the surface. It's 56,000 out there. That's what's causing our global warming. It's getting warmer out there. I'm not saying carbon dioxide doesn't help, but it's not. I think the real source is this rubbing through the ether. And they even had to change the global positioning satellites different coordinates because the magnetic field is moving so fast because it's crashing into these negative particles. It's literally pushing the magnetic pole around the Earth. Seriously. They had to reprogram the satellites so that people wouldn't get lost. They couldn't figure out why. Why is this happening? Well, it's moving because it's forcing it and crushing it and moving it. It's just making a ripple in our space against our planet, and it is pushing our magnetic field. And at the same time, it's creating enormous shifts in these resonance frequencies. And so what? Who cares about that? Well, I care about it, and you should too, because our frequency is at the same frequency, our heart rates and everything are based around this resonance frequency of about 7.83, 7.8, around that area. And now, is what I heard was it's up around 11, which means that we are crushed, and it's vibrating out there much more than it was when it was harmoniously pushing through a light amount of ether. That's the only thing I could think of. And they say that it gets worse. Presumably there is some change due to the solar sunspot ionized change in response to 11-year solar cycle. Now, why is it 11 years? We are being ripped through the galaxy, on an arm of the galaxy, and we are a solar system. I'm going to show you a couple little glyphs about this. But my point is that we are being scrubbed through ether in space. They are negative particles. Those negative particles are light. And I can prove this because I can show you light. And they are negative particles, and they are particles. And they concuss when they slam into other particles or into solid matter. If you force them to crush into themselves, they will turn into plasma. I'm going to show you that. And I'm going to show you what our sun is doing. Same thing we are doing. The sun's corona is millions of degrees out there. Shouldn't even be, it should be freezing cold. Millions of degrees. But the surface is only 6,000 degrees. Why is that? The only possibility is it's scrubbing through the ether in space exactly like we are. And when it does, they're negative particles, and the surface of everything else in the entire universe is negative. Light is negative by itself, but everything else is surrounded by negative particles around nuclear cores. So everything literally is painted with negatives, and as those negatives crush against these other negatives, they create magnetic fields and sunspots and solar flares and all kinds of particle emissions due to these extreme interactions magnetically. It's magnetic interactions. It's all there is. There is no neutrons. There never was any neutrons. So let's go a little further on this. All right, I'm not going to go too deep into the Schumann resonance. Look it up. It's very simple. It's a frequency that is only certain frequencies are capable of existing in this cavity, which is considered to resonate these frequencies. And if they're not correct in that distance, they will not resonate and they fall apart. So there's these exact frequencies, 7.83 hertz, 14.1 hertz, 20.3 hertz. And when you talk about 7.83 hertz, you take 186,000 divided by 7.83 and you end up with 24,890, something like that, which is the diameter of Earth. It all works out, but you got to do a little work here, And then they decline by they increase by 6.5 hertz per frequency jump. So it's fully understood what's happening. They just don't understand why. I understand why. Because the only reason could be because it's crushing into the ether that's coming at it. I mean, it's so freaking obvious. It's just staggering to my mind that it's not understood. Not only that, everybody should understand, way out here it's 56,000 degrees because it's scrubbing as it's swirling through and ripping through the ether of space. And the Earth is 75 degrees. It's 56,000 out here. Why? The only reason is it's scrubbing. Not only that, is twice a day there's high pressure and twice a day there's low pressure. And that is because of spinning, which the Earth does in this ball formation, the globe that it is, against the oncoming ether, which pushes it so that it's compressed at 4 a.m. to 4 p.m. I think it is, and it's it's not compressed at 10 and 10 a.m., 10 p.m. It's just because of the way it spins. It's every 6 hours it changes. It's obvious. And I can draw the drawing. It was very, very simple procedure. And it demonstrates the Earth is spinning and concussing into oncoming ether. It's just as simple as that. Okay, this is what happens when a magnet has repulsion and it keeps its electrons in their orbitals at bay. And it will just continue to keep them out there because there's an excessive amount of negativity here. Now, depending upon the number of electrons in the orbits, it will achieve some form of stability at a certain resonance frequency. That is the key, resonance frequency. Now, what will happen? Eventually it'll settle down. It won't move at all. All the electrons will just be silent. If nobody touches them, if they're going through space and they're just sort of drifting around, nobody's banging into them. But if another bunch of electrons comes along and interferes with it, then everybody starts shaking and bouncing, and who knows what's going to happen. Things could go flying out of here. I mean, it can get really excited. And it will keep pushing and pushing and pushing, depending on how many electrons are coming in and who's banging and doing what. And some of them will just go flying right off of it. This is what I propose is the nuclear core. It's nothing but a zillion little bitty bits of bits. There's some of them are positively net positive and some of them are net negative, but they are all dipoles, I believe. And I'm going to show you why I say that, because the negative ones are. Now don't forget, it's the only possible way you can account for all of these isotopes. For every single molecule, every single atom, every single element has a zillion isotopes, all kinds of different weights, all kinds of different this and that, and they just throw in all these gooey little squiggly lines to make it work. You can't make it work that way. It cannot work that way. It cannot work that way, all right? All right, the nuclear core cannot possibly be working the way they say it is. And I can tell you why I say that. Because I can see these are electrons. It was just a normal red pulsed laser light. And this is something I forgot to really explain to people. This experiment should be done with a pulsed laser light, not a continuous laser. So it's going pop, 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 pop. And the reason you get this is from just a regular cheap construction labor. We use Bosch GLM-15, Rodney and I, and it shoots out pop, 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 like a machine gun. Now, that gives you this concussive effect, and here it's concussing. Now, at first I forgot about the pulsed effect, and now I'm starting to realize that it's probably the reason that we're seeing these electrons shooting almost like single bullets. I'm telling you, it's almost like single bullets. Because if you look back to the area where that particular wave here became, and of course these little dots here are all free electrons in the air that are being concussed as the whole air is being perturbated, they would say, and these are concussing and glowing, just like I showed you with a maggot shaking it around. They're glowing. When they shake, they glow. And I think I understand that too. I'll show you that in, I got it written in one of my books over here, but we'll go over that in a minute. But the wave now is being stretched and elongated and sucked through the venturi. There is no question whatsoever. That is stretched, it is elongated, it is accelerated, it is a particle beam concussing on itself, creating its own glow, showing itself as a particle, and showing an enormous reverse EMF, which is electromagnetic field. And then, of course, the Higgs bosons, then a new particle that nobody knows about, and then the actual bullets, the actual light particles. And I'm going to say that's what they are. And they are dipoles. There is no question about that. And I worked out the symmetry of them. I believe they're cubic dipoles, because nothing is two-dimensional. That's a cube. And I'm going to show you what it looks like in my little drawing, a little Wile E. Coyote for you. Hold on. All right, I got a lot on this, and I got a lot more to go on this, but it must be a cube. This is our four-banger here. You got power, no power, power, no power, all the way around. So you're going to have one on that side, one on that side, one on the top, one on the bottom, like you Rubik's Cube. And that's what this is. So you got a negative and a positive in this band across here. See, this is one big block. So you got your 4, and that makes that block. This one attaches to that one. This one attaches to that one. That's this back. The top comes down, the same thing. They're all, and then the other side comes in from this way. The bottom has the same symmetry, and the other side has the same symmetry. So it's all that way. Now, what would happen if that concussed? If that was just sitting there like a Rubik's Cube sitting on the desk, no problem. But if you came and squished it and tried to twist it, it will force somebody to give off something. And I'm just telling you, it glows. We know that. They used to call them luminous corpuscles, and they're exactly right. Now, not only is this thing built like that we saw it, it controls an enormous, enormous, enormous region. I hope you understand that, because that is the key. You don't see the particle, but the region gets invaded, and that is, well, look at the region that it controls. It's obvious that is the particle. This is the region it controls, and that is actually visible. And you know, it's big. It's like this, really, this big. It's unbelievably big. It's incredible. So they have a lot of power when you restrict them and crush them and force their fields to be literally crushed. And that, my friend, creates plasma, and that, my friend, is all CERN does. That's all they do. But they go head to head with things that are 8,000 times heavier than what I'm using here. We're using light. But I'm going to tell you something. In space, this is going to be just as powerful as proton stuff, because protons are positive stuff. In outer space, it's almost all negative. So we're going to be shooting negatives against a negative backdrop. They're going to be shooting big, heavy positives with some negatives with them, yeah. The positives they're not going to bump against anything. We're bumping negatives against the negative backdrop, because now the whole backdrop of space is light. Light is negative. So this could be more powerful than a proton beam. I'm just speculating. I don't know if I'm right or not. But if nobody looks at it, nobody knows if I'm right or not. And that is light spinning to the right, which means it drifts to the left. It's wider here and compressing there. And that, my friend, is exactly what they say light is supposed to do. Spin to the right. These are the Higgs boson, exactly what CERN says they should look like. Identical. So, last word on this stuff. Thank you. And you know, I would appreciate it if you give me a thumbs up on this stuff. If you're okay with it. If you think I'm doing something wrong, just tell me. So tell me why you don't think it's correct. But you know, I get a lot of people that give me thumbs down just because they hate my ideas about other things in life. I just don't think it's fair. I don't think it's right, and it's really annoyed the hell out of me, perfectly honest with you. But you know, that's what some people are like. All right, thank you.